Good day, everyone. So we are now on our third quarter, and our subject is statistics and probability. Okay, so our first lesson is distinguishing continuous and discrete random variable. Okay, so our lesson objective is first, for you to be able to illustrate random variables, and second, distinguishing between a discrete and continuous random variable. Okay, so let us learn about random variable. So what do we mean by random variable? Okay, it is a function whose domain is the sample space of a random experiment, and the range are values of the set in real numbers. Okay, so you have already learned function in general mathematics. So this is just a review of what is a function. Okay, so a function composed of domain and range. Okay, domain and range, these are set of values. Okay, domain, these are the values of x, and range are values of y. For example, the ordered pairs, we have 2 is to 5, 3 is to 7, 4 is to 9, 5 is to 11. Okay, so the domain here is 2, 3, 4, and 5. The range would be 5, 7, 9, and 11. So this is the function with domain and range. Okay, let us consider this example. Okay, we will be tossing a coin 3 times. Okay, in this scenario, the domain can be defined as the set of all possible outcomes. Okay, of this experiment. The range of the random variable as the total number of tails that comes out after tossing a coin 3 times. Okay, so the domain here is the set of all possible outcomes. So that would be the domain. Okay, the range would be the result or the values of those outcomes. Okay, values, you will get the values of let's see the values of y. So y would be the range. Okay, so here we will be looking at the value of uh, the number of tails. Okay, so the number of tails will be our range. Okay, so we will count the number of tails from all possible outcomes in each set. Okay, for each element in the domain, there are a corresponding value for the random variable y. Okay, the specific value of the random variable is denoted by a small letter. The domain and range of the random variable y are shown in the table below. Okay, so here is the sample of the values of the random variable y. Okay, so y is our range. Okay, so y, the value of y is attained through counting the number of tail that comes out from the experiment. Okay, so we have here the first set. Let's say you toss the coin for the first time. The first set of tossing a coin 3 times, okay, all outcome became the tossing resulted from all of the tossing of the coin got all heads. Okay, so if we counted the number of tail, so it would be none or zero. Okay, the second set, we have a tail that comes from that we have from the outcome of this set. Okay, we have one tail. The next set, we also have one tail. Okay, and so on. Okay, so therefore, the values of the random variable, okay, all possible outcome, if we will look at the range, okay, what could be the possible outcome? So all possible outcome of the number of tail could be 0, 1, 2, and 3. Okay? Again, the possible values of the random variable are 0, 1, 2, and 3. Okay? So random variables can be classified as either discrete or continuous. So we can classify them either discrete or continuous. So how could we determine if this is a discrete random variable or a continuous random variable? So let us define the discrete random variable. Okay? It is a random variable whose set of all possible values are countable or infinitely countable. It can be represented as a separate points on a number line. Okay? So from the word countable or infinitely countable, okay, the values can be counted. Okay? Example. Okay? So when we say countable, we can count the values. Okay? The number of correct answers in a 5-item true or false quiz. Okay? So we will count the number of correct items. So that is a discrete random variable. The number of people in a country. Can we count the number of people? Yes. Okay, so how do we do it? We get the population count of a country. Okay. Next is the continuous random variable. Okay. It is a variable whose set of all possible values are not countable or infinite. It can be represented as an interval. Okay. So when we say it is not countable, how can we get the values? Okay. It is still a variable. It only means that it also have values. So how can we get the values of the continuous random variable? Okay, we can measure it. So if it is not countable, then it should be measurable. Okay, example. Okay, the height of each student in a class. Okay, so a height could not be counted, but it is measurable. Okay. Next is waiting time before a person gets a taxi in a taxi stand. So the time spent. Okay, you cannot count how many time, but you can measure how long. Okay, how long before a person gets a taxi. Okay. So if it is not countable, it must be or it should be measurable. Then it is a continuous random variable. Let us explore. Name one discrete random variable and one continuous random variable related to the things that you can see inside a classroom. Okay? How do you get the values of those random variable? Okay? Let us name one discrete random variable. Okay? We have chairs. Okay? So we can see chairs inside a classroom. So how do you get the values of those variables? So we can count the number of chairs inside a classroom. Okay? So that is one good example of a discrete random variable. Let us name one continuous random variable we see inside a classroom. Okay? So we can get the value of this variable through measuring. One good example is the length of a blackboard inside the classroom. So we can get the value of the blackboard through measuring. Okay, so we will measure the length of the blackboard. So that is one good example of a continuous random variable. Let's try this. Determine whether the variables is discrete or continuous. Okay, number one, number of leaves in a 10-week-old plant. Okay, so how many leaves would be there in a 10-week-old plant? Okay. Number two, amount of time rendered using a social media application. So how long would a person render a time using a social media application? Okay. Number three, temperature of air in different times of the day. So how will you get the temperature? Let's say 7 o'clock in the morning, or 10 o'clock in the morning, or let's say 1 o'clock in the afternoon, or 5 o'clock in the afternoon. Okay. Number four, rating of an employee in a 10-point scale. So how will you rate an employee? And number of coins in a piggy bank. So what will be our answer? Okay. All our answers will be, for number one, it is a discrete variable. Why? Because the number of leaves can only be represented by a whole number. So we can count the number of leaves and can be presented by a whole number. Okay. Number two, it is a continuous variable because the amount of time it can be any value within a certain range, thus its possibilities cannot be counted. Okay, so hindi natin yun basta mabibilang. Okay, it can only be measured. Okay. Number three, it is continuous variable because air temperature can only be valued within a range. Okay, thus it cannot be represented by a whole number alone. Okay, so it is measurable. Number four, it is a discrete variable because the rating can be just the whole number from 1 to 10. Okay. Number five, it is a discrete variable because the number of coins inside the piggy bank are countable. Hence, it can be presented as a whole number. Okay, here are the tips on how you will identify discrete or random variable. Okay, there are cases of discrete random variables that may have infinite values or um, senseless to count because it is infinite. Okay, for instance, okay, the experiment is counting the number of sand in beaches. Although it would be impractical and senseless to count the number of sand in beaches, okay, the kind of random variable it would generate is still discrete. Okay, so if ever there are researches that counts the number of sand in the beaches, then it is a random variable. Okay, key points. Random variable is a function that takes on all the possible outcome of an experiment and assign for each of them a corresponding real number. Discrete random variables are countable and countably infinite, while continuous random variables are not countable or infinite. Okay, so that's it for our lesson. And thank you for joining me for today. Okay, I'll see you again. Thank you and have a nice day.